In this video, I would like to go through an example of a numerical problem in which you need to calculate portfolio expected return. So where do we have a portfolio in this problem? We are investing our money into 4 different company stocks simultaneously, A, B, C, and D. So this is our portfolio, right? Portfolio. How much are we investing into each company stock? It's what we call stock weights. So this is percentage of your money invested into each company's stock. Each company's stock shares, right? So it's just percentage of your money. That's really all that the word weight means. Okay, if you buy just shares of stock of firm A, you get an increase of your money by 15% if it's a so-called good year. Otherwise, if it's not a good year but a bad year for the company, in which case the company cannot pay you as high dividends and so on, the return on your money will be only 5%. Same for stock B, the good state of the economy and the bad state of the economy, 12% and minus 8%. Stock C, 3% if it's the good state, 10% if it's the bad state. Firm D, 30% if it's the good state, 70% if it's the bad state. By the way, the names for different states of the economy or different scenarios are kind of, they may be misleading. Good doesn't always mean that for that company the return is high. For example, for firm C, it's only a 3% return if it's a so-called good state. But it's a much better return, 10%, when it's a bad state. So the names of states are kind of misleading. They're just names. Think of them as just names. Don't really, pay close attention to them. They don't really mean anything. So we have probabilities 40% that the good year will happen every year in the future. And with probability 60%, which is the remaining probability, a bad year will happen. So these are the returns that are given, and the weights of your stocks in your portfolio are 10% in stock A, 20% in stock B, 30% in stock C, and 40% in stock D. Okay, let's solve this problem. There are a couple of different ways. Let's look at the first method. Let's look at the good state, right? So we can calculate if the good year takes place in the future, let's say next year, then what will be the portfolio return in this case? Portfolio return. Well, here's how we should think about it. 10% of our money will increase by 15%. So let me do everything in decimals. 0.1 times 0.15. Then another 20% of our money will increase by 12%. That's stock B. So in decimals, 0.2 times 0.12 plus 30% of our money will increase by 3%. So the weight of 0.3 multiplied by the return on stock C of 3% or 0.03 in decimals. And then we have firm D stock, the last one in our portfolio. 40% of our money will grow by 30%. 0.4 times 0.3. And when you do the math, you'll see that this equals 16.8%. So 0.1 is the weight, and 0.5 is the return. of that particular stock for which you're using the weight. Then we do the same portfolio return in the bad state of the economy. So bad portfolio return if the bad year happens. What we are gonna copy and paste from the line that we already have is the weights. So 0.1, 0.2, 0.3, and 0.4, all multiplied by the return. So now only the returns need to be updated, and we take them from the bad scenario, the bad state of the economy. So it's now 5, minus 8, 10, and 7. Or in decimals, 0.05 minus 0.08, then 0.1 and 0.07 for the last stock. You do the math, you get 4.7%. Actually, because I used everything in decimals, it's really, for the good portfolio return, it's 0.168, and for the bad scenario, it's 0.047. But I'm writing the numbers in percent, to match sort of how the information was given to us for individual stocks. And then what do we do? Then you have one step left. So 16.8% return is for the good scenario, which will happen with a 40% probability. So now we can calculate expected portfolio return, where we take the probability of the good scenario, 0.4, we multiply by the return on the portfolio in the good scenario, 16.8%. And then we add the probability, right? These are probabilities, of the bad scenario, 0.6, multiplied by the return on the portfolio in the bad scenario, 4.7%. And this gives us the answer, 9.54%, rounded to 2 decimal places. So this is one way of calculating portfolio return. And now expected return on the portfolio. Now let's look at a different solution. Instead, we can calculate expected return on stock A, then expected return on stock B, then expected return on stock C, expected return on stock D, and then we calculate expected portfolio return as the last step. So what's the expected return on stock A? Look at the column with stock A returns, 15% in good, 5% in bad. So there's a 40% chance that we get a 15% return. Okay, 0.4 times 0.15 plus there's a 60% chance we get a 5% return. So 0.6 times 0.05, which gives 9%. Then the same way we go through the remaining 3 stocks, B, C, and D. So one thing that will stay unchanged is the probabilities, 0.4 and 0.6. 0.4 for stock C, 0.6 for stock C, 0.4 for stock D, 0.6 for stock D. And the only thing that's changing is the returns for the 2 possible states of the economy. So for B, we're going to be using 0.12 in decimals and minus 0.08, which will give us actually 0%. Then for C, we have the returns from the column for stock C, 3 and 10, or in decimals 0.03 and 0.1, which gives us 7.2% for the expected return. And for D, we use 30% and 7%, so 0.3 and 0.07, which gives 16.2%. And then in the last step, we are using what? We haven't used what yet? We haven't used the weights, the proportional, the percentage of our money invested into the 4 stocks. So that's what we do in the last step. Okay, so we do 0.1 times, so 10% of our money is expected to grow by 9% every year, the expected return, right, of 10% of our money. So 0.1 times 0.09, plus, eraser, plus 20%, right, of our money will grow by 0%. So let me not skip it, but keep it, 0, plus 30% of our money will grow by 7.2%. So 0.3 times 0.072. And the last stock, stock D, the fourth one, 40% will grow by the expected return of 16.2%. So 0.4 times 0.162. Right, so we have 4 components, which are the products of the weights by the expected returns from the calculations on the left. And that also gives us 9.54%. So it doesn't matter how you do the math, which method you follow, because either way you're going to get the same results. And the one kind of quick tip, whenever a problem asks you to calculate expected something, a good, trick to remember is that the word expected means what? It means use probabilities. Use probabilities. So we calculated expected portfolio return in the first method, where the probabilities we used were 0.4 and 0.6 for the 2 possible outcomes. And then in the second method, where did we use the probabilities? We were using them earlier on in our steps. So we were right away using the probabilities because we were immediately calculating expected returns for the 4 individual stocks. So in the second method, the probabilities are used kind of early on, and the weights are used towards the end. Whereas in the first method, we use the weights right away, and then we use the probabilities towards the end.